Assalamualaikum warahmatullahi wabarakatuh. This will be a simulation video for mid-semester examination from semester 2 2022 2023. Meaning at the point of recording, this is previous semester's midterm 1 exam. Several notes before we go into this. Number one, I have given all the resources that I think is needed for the students to take the midterm 1. However, some students actually ask with regard to, because the previous or past midterm exam that I have made available mostly are from previous semester when we only have one midterm exam. Hence the chapter that is included is perhaps until chapter 4 or 5. But this semester, just like last semester, we have two midterm exam. Hence the first one will cover only chapter 1 until 3, and I haven't actually done any recording or any simulation for that particular range of chapter. Even though all the resources, of course, on top of the lecture videos and slides, we also have the tutorial questions that should already be enough to cover the topics and some example questions. But as a package of simulation for the midterm 1, I just realized that I do not have that yet. Hence this video is to provide for that. Hopefully it will be helpful for some, at least, inshallah. That's number one. Number two, I managed to track back this question from past semester, the mid-semester examination for semester 2 2022-2023. However, I couldn't find the solution or the answer scheme. Hence, I will go into this just like I go into most of my tutorial videos, where I will be answering on the spot. Hence, there is some possibility of mistake happen, because I'm just human without ability to referring to the actual answer. If I make a mistake, I might not realize it, right? So just like if you have watched the tutorial video, some student actually commented, oh, they noticed some mistake, especially in the calculation sense, because I'm just straight away using my calculator and go forward. So if you notice any of those, feel free to comment down so that other students can benefit from from being alert of any such mistake. Hopefully it doesn't happen that much or at all, but I'm just saying that it might happen. That's number two. Number three, this is not the best or most conducive setup and place for me to do this, but because for this semester, at the time of recording, the midterm exam, the first midterm exam is the day after, tomorrow. Hence, this is the only opportunity that I have, so we'll have to go forward and let's see how it goes. So yeah, of course, the lack of convenience and ergonomic of this place perhaps add to the challenge, but still that can be considered as part of the package of answering this exam within the time frame that is given, right? So I hope you can see that currently it is 11:32 p.m. here, and this exam from past semester, the time given is from 8:30 to 10, which is 1.5 hour. So we'll target for that, right? So current is 11:30, so I should be able to finish this by 1 a.m. So that's number one. Of course, that's why in this simulation, the process is as just like what you will be facing in the real exam. We will be doing some thinking 1 or 2 minutes before actually going to solve, etc., because that's normally the best practice before rushing through, right? And we will see whether by doing that can we still finish on time. That's number one. Number two, in reality, I think you will not be talking like this because we already have 3 minutes in, and so hopefully in reality the ability to finish before the actual length of this video should be very much possible. So I have my calculator here and this one to maneuver So we'll go about this one. So let's assume we have started at 11:30 and we have 1.5 hours until 1. Right, so let's go through first the whole paper, make sure the paper is correct, the question is clear, etc. Right. So first thing you have to know that it's 1.5 hours. You have to budget your time. In this particular exam, we have 2 questions. One is 60%, second is 40%. So make sure you are aware of the mark distribution and plan accordingly to secure most marks possible. Question number 1. So let me just, alright. So question number 1 gives you 60%, should be consistent here. So here you have, this is chapter 2, I believe. So if you can see, you need to find the resultant force. You need to find the direction, meaning the angle of the resultant force, because this is in 2D, and meaning you have to provide for theta, and then find F1, F2, F3 as Cartesian vector, meaning that we have to express all of this in Cartesian vector IJK. Second part of this question, part D, E, F, G, based on figure 2, which is this one. 2 forces acting point A, determine the following Cartesian vector representation. Okay, so we have to get these two in Cartesian vector. So here we have to use projection angle like this. Here we will have to use coordinate, basically, right? Based on the information, we have to use coordinate, get the position vector, unit vector, and then vector of the force. Find the resultant. So if you have the two, you can add. Find the angle. So this is normally, if you see this kind of question, you know straight away you will need to use dot product. So if you have the two vector, you can do this. And projected component also dot product, right? So when you go through, at least you know, this using what, and then you can allocate which one you want to solve first, right? And then question number 2 for 40 marks. So we have 2 parts as well. The first part, based on this figure, determine the tension in each cable. Right, so basically this is equilibrium problem of a particle. So you have to consider this point C and D, and free body diagram, equation of equilibrium, right? Second, cable BC is replaced by spring, blah blah blah. Okay, normally when you have question like this and justify your answer, normally it's a logical question, it's understanding question. So most probably it doesn't require calculation, but understanding to answer. Part C, based on figure 4. If you have textbook, some of the question you might notice that this is from the textbook, right? Where's ball pack, there's a spring. So this is a spring pushing up, and then you have the cable. Determine the point of attachment A, X, Y. Okay, so in this case, sometimes question like this will come where if you have done some exercises from the basic question, normally the flow is all the coordinates is given, etc., and then you find the force. But some question can reverse the flow, so meaning from the force how to get the coordinates. So normally that will become a bit more complex for some students, even for me, because it does push you to think a bit how to reverse the calculation. So this question is as such, but it just use the same concept. So let's see. Alright, so based on that, that's what given. So we have the two main question, where actually essentially there's 4 questions if you see, right? Because there's 4 diagram, so there's 4 sub questions. Alright, so we have spent 7 minutes going through. Normally in the real exam it just take most 5 minutes hopefully, and then you're set, right? So in this case we'll just go with the flow. Alright, bismillah. So just to go to the question again before we solve it, right? So in this question we are given this diagram where we have 3 forces. All the magnitude is given, the angle all are given, so it's straightforward. Find the magnitude of resultant force. Alright, so we'll put this aside. Hopefully this is still visible. We'll have to use a smaller one. So I hope it's still visible. We have seen the question before, so here you just want to see the diagram, and we'll answer over here. Alright, so first, this is question 1A, right? Okay, the setup here. Oops, my hand is not in the. It's not in the. My hand is not in the normal position, so it's very hard to write properly. Okay. Right, but by the way, if you are an IIUM student, you know that some of our facility in the kuliah is also creating this kind of challenges, right? Meaning that sometimes if you have, I'm not sure if you are taking statics, you might probably be the first semester student, first semester, so you might not know yet this. But if you have been here for several semesters, you have taken exam before. Sometimes the table, the chair of the examination hall is sometimes shaking, etc. So it's not ideal. So yeah. Anyway, not to badmouth our university, but the students should file a complaint to improve this condition. Anyway, so so what is needed here is magnitude of resultant force. So what we need in the end is FR, right? So this is what we need as a resultant of the three forces. So if we can get the so I will express, okay, how exactly you do. There are several ways. Sometimes some students straight away go summation of fx, summation of fy. For me, normally I like to express each forces first, so that when I do how to say, because normally before you submit, you just want to revise everything. So if you do very structured, normally it's easier for you to track any mistake. If you just jump certain steps, sometimes certain steps is not compulsory. You will not lose marks because you do not do it. But if you want to recheck, sometimes it's more complicated because you have to, you know. So that's my advice generally. If you can do a very structured way, it can be very helpful. So let's see, if I say f1 as a vector, but we will already answering part C, right? Should I do that? Okay, it's interesting because the flow of this question, right? So okay, let's do this. F1, okay, because this is part C, so I'll skip this one then, because it will appear in part C, so it'll be waste of space. But anyway, normally I would like to start with that because it's easy to check. But here, let's just straightway jump into this summation of fx. If you take to the right as positive, right? So f1 is to the left, so it should be minus 400, and then sine 70, and then f2 200 also to the left, so minus 200, 4/5, and then 500 to the right, so plus 500, cos 45 degrees, right? Now for 45 degrees, cos and sine is the same, right? But it should be consistent with the diagram. So if the diagram have this angle here over here, so this should be the cos and this should be sine, right? So it should be consistent. Otherwise, we do not know whether you are doing correctly or you are just lucky. Anyway, so minus 400 times sine 70 minus 200 times 4/5 plus 500 times cos 45. So minus 182.3236237 Newton, right? So double check. Minus 400 times sine 70 minus 200 times 4/5 plus 500 times cos 45 minus 182.3237. Alright. Take note of the significant numbers, right? So at least 4, but for more accuracy like this is 6. So is it 6, 1, 2, 3, 4, 5, 6, 7, right? So I always have the habit to have as much as possible to avoid having error. Of course, if you have 4, or in this case 2 decimal point, that's normally enough. But if you have less than that, normally you will be penalized because not enough. Anyway, so summation of fy, so f1 is downward, so minus 400 cos 70 plus 200 3/5 plus 500 sine 45 degrees. Alright, so minus 400 times cos 70 plus 200 times 3/5 plus 500 times sine 45. So it's 336.7453. Double check. Minus 400 times cos 70 plus 200 times 3/5 plus 500 times sine 45. 336.7453. Alright, so what this mean, because we want to find the resultant, right? So what this mean is we actually have okay, pardon for the angle, because this whole thing is not it's difficult to write here. 182.3237 Newton. Sorry, not okay, anyway. Negative doesn't make sense in this case, right? Because negative is to the left, so the value is 182.3237 Newton, and then upwards. Okay, so let me what? Okay, banyak kerja lah pula. Okay, because this is upwards, right? So okay, just scratch this. Okay, so because it's to the left and upwards, right? So it's to the left and upwards. So here is 182.3237, then this is 336.7453 Newton. Now so we have FR, and then we have theta that we have to find, right? But for part A we have to find FR, and for part B we'll have to find theta. So FR then is simply square root of 182.3237 square plus 336.7453 square. Oops. So here we should have square root of 182.3237 square plus 336.7453 square. We get 382.9351 Newton. So verifying square root of 182.3237 square plus 336.7453 square, 382.9351. Alright, so of course, as the final answer, normally we don't take that much of a significant number, so 382.9, then that can be the final answer. Alright, that's part A. Okay, so part B, so is the direction, right? Is the direction. Okay, can we see this? The direction of resultant force. So basically, because we have drawn here, so theta is there, right? So it should be understood here. So theta is tangent minus 1, opposite adjacent, right? 36 point. So 336.7453 over 182.3237, right? Means tangent 336.7453 divided by 182.3237, so you'll get 61.6 degrees. Of course, if you want to put here, in this case the drawing is there, but because the value and which quadrant should be very clear, right? So in this case it's clear, but if you just want to add, so it's just like that, right? That is theta in that quadrant, right? So alright, and what do you need for part C? Each one as Cartesian vector. So question 1C. So let's express each as Cartesian vector, right? So F1, so to the left, so minus 400 sine 70 degrees I, and then downwards minus 400 cos 70 degrees J. Of course, it doesn't have any K value because it is 2D, right? So minus 400 times sine 70, you'll get minus 375.9 I. If you take one decimal point, 375.9. Now here, because we straight answer part C, right? Because then that's the final answer. But if you do Cartesian vector form first to answer part A to get the resultant, this significant number here is not enough. Or normally I would consider one decimal point is not enough normally. So you have to take more, just like we have done earlier, right? So it depends where you are doing this. As a final answer, this should be sufficient. So again, 400 times sine 70, you have 375.9, and then 400 times cos 70, again minus 136.8 J. Don't forget the unit. Alright, so F1. What about F2? So F2 to the left, so minus 200, 4 over 5 I, plus 200 because upwards, 3 over 5 J. Right, so if you calculate 200 times 4 over 5 minus 160 I plus, I shouldn't use calculator for this one, right? But 120 G Newton. That's F2. What about F3? Where's my mouse? F3. So 500 cos 45 degrees I plus 500 sine 45 degrees J. So 500 times cos 45 353.6 I. It should be the same, right? 500 times sine 45, just checking, 353.6 G Newton. Alright, so that means we have completed this part A, B, C, right? So we have to find, let's see, we have to find the magnitude, we have done, of the resultant, direction, we have done, force as characteristic vector form, we have done, alhamdulillah, right? So moving on to the next part, right? So for the next part, part D, E, F, G, based on this figure, alright, so we have to find Cartesian vector first, and then resultant, and then angle, and then projected component, right? So let's have this diagram where we can see it, because we need the values here. Okay, where should I put it? Something like here. Okay, my face will be where? Okay, I put here lah. I didn't think where I want to put this. Anyway, so we will have the second part here, right? So we'll begin here at a new. Alright, so question 1 ABCD, right? D, correct? This is D. Yep, D. Alright, so we need to find vector for each. So for FAB, we can straightaway use all this angle, right? Because this is projection angle. So for FAB vector, you can straightaway use. So x component, so x positive is here, y positive here. So in this case, x is negative, y is also negative, z is of course negative because it goes downward, right? So in this case, negative 400 for the x component, sine 50 degrees, then 3/5 I, right? 50 sine, and then 3/5 to get x there, right? Okay, and then y is also negative there, so we have minus 400 sine 50 degrees, and then 4/5 J, right? Now if you still need to do the two triangle, please do so. Do not assume, do not guess, you know, make sure you avoid any mistake. So if you have to draw the two triangle to get this, draw the two triangle, and then minus 400 cos 50 degrees. Okay, yeah, so it's not worth to gamble at this point in the exam. But if you already have done enough exercises, normally this one you can just by looking you can do, right? So from here you get, because you have to express, so you have to find until the end, minus 400 times sine 50 degrees times 3/5 minus 183. Now we will need to find resultant later, so I'll take enough significant number or decimal point. 8507 I. Okay, so double checking, 400 times 3/5 times sine 50, 183.8507. alright, and then minus 400 times sine 50 times 4/5, 245.1342 G. Double check, 400 sine 50, 245.1342, and then minus 400 times cos 50, 257.1150 K. Enough, please. A bit more. Newton. right? Because we have, when we have to express, it should be full answer, right? Now you have to differentiate between, if the question do not ask this as one particular question, it just straight we ask resultant force. This is part of, this is like intermediate calculation. So if you do not write Newton, etc., we may still accept. But if this is an answer, because part this is what is the vector representation, so it should be full answer with the unit, etc., etc., right? Okay. Of course, as an answer, you can truncate this into, for example, okay, minus 183 point, let's say 85i minus 245.13 j minus 257.12 k Newton, right? You can do that as final answer, but to calculate for resultant later on, you have to do with the more accurate number, right? So this is FAB, but for FAC we need the coordinate, right? So for FAC, so we need the coordinate. So it's basically from point A until point C, right? The coordinate point A is 0, 0, 4. The height is 4. Coordinate C is x is 3, right? 3, 5, 0, right? So from here, double check. So 0, 0, 0, 4, 3, 5, 0. All right. So from here, REC is 3i plus 5j minus 4k, right? So REC, the magnitude, square root of 3 squared plus 5 squared plus 4 squared equal to 3 square plus 4, 3 square plus 5 square plus 4 square. 5 square root of 2, 5 square root of 2, or 7.0711. So 7 from 07106, so 11. Alright. So again, square root of 3 square plus 5 square plus 4 square. So unit vector, unit vector UAC is basically RAC divided by RAC. So 3 over, okay, 3 divided by, so basically you get all of this is positive, right? 0.4243i 4243, 3 divided by 0.7 4243. Alright, and then 5 divided by, so you'll get 0. Plus 0.7071 j, 5 divided by 0.7071. Alright, and then minus 4 divided by 0.56 57, right? So 4 divided by 5657, right? That's unit vector. And then where's my mouse? Okay, so what is F AC is basically F AC times UAC, right? FAC is 500, right? Or basically 500 UAC above. So it would be 500 times all of those. 500 times 0.4243 212.15 I plus 500 times 0.7071 353 55G minus 500 times 0.5657 5657 282.85 K Newton, right? So this is what we need, the expression of each. Where's my mouse? So that's the first answer, this is the second answer, right? So that's question 1D. Next question 1E is the resultant of the two forces in terms of magnitude and direction. So we need to find basically what is FR magnitude and what is the direction, meaning alpha, beta, gamma, right? Alright, so FR in terms of vector, we should be able to straightaway calculate, right? So this will be FAB plus FAC, right? So FAB plus FAC. So we'll have, how can I see both? Okay, I have to keep on scrolling. Anyway, so it is minus 183.8507 and then plus 212.15. Oh, I didn't take much. Anyway, so 28.299 become 30I okay, and then second for for J minus 245.1342 plus 353.55 108 plus 108.42 G, and then 257.12 282.85 minus 539.97 K. Five 39.97 okay, Newton. Of course, this is not the final answer yet because we need the magnitude, right? So FR magnitude will be 28.30 square plus 108.42 square 539.97 square to 8.3 square 108.42 square 539.97 square. So it become 551.47 Newton. This is the magnitude of the resistance. Checking. 28.3 square plus 108.42 square plus 509.97 square, 551.47. Alright, so that's magnitude. What about alpha? So alpha equal to cos minus 1 to the x component is 28.30 divided by 551.47. So it will be 28.3 divided by 551.47, 87.1. What about beta? Cos -1. Okay, let's double check. 28.3 551, right? Okay, 87.1. okay, and then 108, oops, 108.42 divided by 551.47. that should be 108.42 divided by 551.47, 78.7 degrees, 78 point. Alright, and then gamma cos -1. So what is it? Negative 539.97. Negative 5. What is that? 39. 39.97. 97 divided by 551.47 equal to cos minus 539.97 divided by 551.47, 168.3 degrees. degrees. Alright, so that's part E, right? Part E, resultant in terms of magnitude and direction. Alright, so we have magnitude and direction. Now we need to find angle, so 1F, right? Is it the end already? Okay, we need more space then. Alright, so part 1F, right? Question 1F. What was it? The angle between FAB and FAC. So because we already have both vectors, so it's straightforward, we will use it, right? So basically, from the concept is basically A dot B equal to AB cos theta, and we want to find theta, right? So basically we will use FAB dot FAC, FAB FAC cos theta. Yeah. Now you have to write this before you actually calculate so that we know what is going on, right? So FAB.FAC, because we have already expressed it, because however, to make it easier for me, because this is FAB, right? Because keep scrolling like this is quite difficult. If it's in paper, it's quite easy, but here we have to scroll and scroll and scroll. So I'll copy this one. Okay, so this here, this is FAC, right? Oh, alright, so if you dot these two, okay, sorry, this should be here, otherwise I will have lots of marks because it's vector, not magnitude. Alright, so FAB.FAC, so if we calculate FAB.FAC from both vector, if you straight away calculate, because so this multiply by this, etc., right? So minus 183.85 times 212.15 becomes negative 39003.78, right? Minus 183.85 to 12.15 minus 39003.78, right? And then minus 245.13 times 353.55 minus 665.71 245.13 353.55 86665.71, alright? And then 257.12 times 282.85 plus 726.39, so equal to minus 3903.78 minus 86665.71 plus 72726.39, so you'll get minus 52943.1. double check. Minus 39003.78 minus 86665.71 plus 72726.39 minus 52943.1. Alright, so that's the left side of this equation. So basically, hence you have minus 52943.1 equal to, it should be FAB FAC cos theta, right? FAB FAC we know from the question, 400 500 cos theta. So cos theta equal to, if you calculate this one, minus 52943.1 divided by 400 divided by 500, so you get minus 0.2647, meaning theta is 105.4 degrees. This is the angle between them. So we have our cos minus 0.2647 47 to check 105.4 okay, so 0.3, right? This depends how much decimal point you take. So for theta, it is actually significantly affected if you truncate that much or you round off that much. So cos minus 0.2647, it become 105.3. But if earlier when we divide, let me just see the value, 52943.1 divided by 400 divided by 500, what, 52943.1 divided by 400 divided by 500, 0.2647. If we take, for example, 155, if you do cos negative 0.2647,155, then you get 105.4 basically, or 35. So you can see the decimal point does have some value effect. So that is 1f. Right, for angle between FAB and FEC. Now we go to G. Question 1G. What is the projected component of FAB on the line AC? Right. So basically this is FAB on the line of AC, right? So it should be FAB dot UAC. That's one way of calculating it. Now, if you want to use theta, you can also say FAB AC should be FAB cos theta, right? It should give you the same answer. However, if you select the second equation here, your answer will be dependent on the previous question, because your theta is the one you calculated yourself. If you make a mistake there and then you use into here, then the answer here will be also wrong because it is affected by theta here, right? So that's why normally, personally, I would suggest you use an equation that is independent of your previous answer, meaning that here, of course, even though FAB and UAC is something you calculate yourself as well, but it's much earlier compared to theta. But it's up to you, and you can verify whether it's correct or not if you calculate both. So we will use the first one first, right? So FAB we already have. Let me just collect this one. Of course, I can just in exam we just rewrite, right? Because we cannot copy and paste by here. And UAC, right? UAC we have here. Okay, this is quite long because we already reached the end already. So I have to again. Oh, I cannot already. So it's already at the bottom. Alright, so let me. Oops. Alright, no. What do I? Okay, so we are doing FAB UAC. Okay. Kaya tengah malam pula nak congkak. So FAB dot UAC. So if we do so, okay. Oh, where's the brush? Oh, the color. So FAB parallel to AC. if you use fab.ac, we have already written there, it will become minus 183.5 times 0.4243 minus 78.01, right? Minus 183.85 times 0.4243 minus 78.01 minus 245.13 times 0.7071 minus 173.33 257.12 0.5657 plus 145.45, so minus 78.01 minus 173.33 plus 145.45. So it have minus 105.89 Newton. Now, if you have this negative, you have to explain what this means, because there's no such thing as negative force, right? You have negative Celsius, for example, right? Temperature below 0 is become negative, and it is understandable. But for force, there's only force. So the negative means the opposite direction, right? So this would mean opposite direction, or in other words, direction of CE, right? Because we assume if you understand this equation, FAB.UAC, you already assume the force is in the direction, the projection is in the direction of AC. But when you get negative, meaning it's CA direction, right? So that's sufficient. Now, if you want to use the second equation, FAB projected on AC is FAB cos theta. If you do that, so FAB equal to FAB projected onto AC is FAB. So what's the magnitude of FAB? 400 cos theta. Theta is what we have just now, 105.4 degrees. What you get is 400 times cos 105.4 degrees. You get negative 106.22 Newton, right? Again, negative is opposite direction, right? However, you can see this error between the above and below, right? This is pretty much with respect to, one is how much error that we have in the theta, second how much error that we have in all of this FAB and AC, right? So the more the less, meaning the less significant number or decimal point that you take, normally the error become much larger, right? So yeah, that's how it is affected. And we can see here earlier when we discussed about this, right? Is it 105.3 or 0.4? It depends on above, right? But here, if we have, because it's 1.35, right? So if we have 400 times cos 105.35 earlier, if you take two decimal point, it becomes 105.89, which is exactly the above, right? So for example, here, when we take 0.35, it will lead towards this exact answer. You can calculate yourself, right? 105.89, right? So that decimal point is important, because here as a final answer is okay, but as a calculation, that's why when we say if we are still calculating, the value shouldn't be rounded off that much yet, right? Because here is 35, right? So if you bring here, you can see how it is affected. It can be seem quite significant. 105.9 or 89, 106.22, right? That's a big jump already, because of just these differences, because this one is rounded off already, right? So that is question 1 is, that's finished question 1, right? Projected angle. So now we go to question 2. Right, so question 1, so basically question 1 we have finished, and we took how many, because we started at so we only have 30 minutes left. Okay, we have to rush, and maybe I'm talking too much. Anyway, so we'll go to that one, the third question, right? Third part. Of course, in reality, you will not want to talk too much. Second, because I always double check everything and even explain, etc. So it does take more time. So let's see, can we finish on time here? So here, we need to determine the tension, etc. So we need to draw the free body diagram. All right, and equation of equilibrium in each cable, right? So so here, question 2a. Question 2a. Right, so here what we have, okay, what is the information? The system cable suspend 15 kilogram. So the information that we have is the lamp is 15 kilogram. So we'll start point D, because that's where we have the value, right? So here we have 15 times 9.81 Newton, and then we have FDE with the angle of 25 degrees, and we have FCD, right? So if you do summation of Fy equal to 0, taking upwards as positive, so FDE sine 25 degrees minus 15 times 9.81 should equal to 0. This would give FDE is 15 times 9.81 divided by sine 25. Okay, so 348.19 Newton. Basically, that's the answer, because we need to find each the tension in each cable, right? So this in tension, this is in cable FDE, right? So just to verify, 15 times 9.81 divided by sine 25, 348.19. All right, and then we do summation of Fx. So FDE we already have, so 348.19 cos 25 degrees minus FCD equal to 0. So from here we have FCD equal to 348.19 times cos 25, 315.57 Newton, right? So 348.19 times cos 25. All right, now we have this value, we can go to the next point, which is point C. So okay, this is FBD of point D, right? So if we proceed with FBD of point C, so we'll have FCD, which is already known as 315.57 Newton, and then we have FAC with the angle of 345, and then 30 degrees is there, so meaning this is 30 degrees, right? So here is FBC, 30 degrees there. Yep. Okay, so here if we do summation of F, okay, because this is a simultaneous equation, right? So let's say summation of Fx equal to 0, to the right as positive, so you have 315.57 minus FAC times 3/5 minus FBC cos 30 degrees equal to 0, right? again 315, FAC 305, FAC cos. Okay, so we have to shuffle to get one, because this is simultaneous execution. So let me just do this. FAC 3/5 equal to 315.57 minus FBC cos 30 degrees, or FAC equal to, bring over there, 15.57 times 5 divided by 3 becomes 525.95 minus minus FBC 5/3 cos 30. Okay, sorry for the small space there, right? 215.57 times 5 divided by 3. Okay, so we do some summation of Fy equal to 0 if we take upwards as positive. So we'll have FAC 4/5 minus FBC sine 30 equal to 0, right? And then we can plug in the above here. We should number it, right? For example, this is number 1, this is number 2. So if we go 1 inside but 2, so we'll have, so FAC is all of those, right? So we have 5 to 5.95 minus FBC 5/3 cos 30 degrees, all of this times 4/5 minus FBC sine 30 degrees equal to 0. Alright, so if you just multiple that 1.5 to 5.95 times 4/5, 4 to 0, 4 to 0.76, and then minus, so we will have basically, because this okay, FBC 4/3 cos 30, right? And then minus FBC sine 30 degrees. So if we do this, actually it'll become, so if we have in other words, right, so if we reshuffle this one, FBC 4/3 cos 30 plus FBC sine 30 equal to 4 to 0.76, right? So if you calculate this one, 4 divided by 3 times cos 30 plus sine 30, so you'll get 1.6547 FBC equal to 4 to 0.76. Again, 4 divided by 3 times cos 30 plus sine 30, is it correct? 1.6547. Alright, so 4 to 0.76 divided by 1.6547, you get FBC equal to 254.28 Newton. Now we have FAC remaining, right? So FAC here. So FAC is, oops, what is this? Okay, what is happening? Okay, so hence, oops, Okay, something is going on. Okay, so F is C is, what was the above? 525.95, 525.95 minus FBC minus 254.28 FBC, 5/3 cos, 5/3 cos 30 degrees, right? So it will be F is C 525.95 minus 254.28 times 5 divided by 3 times cos 30. It becomes 158.93 Newton. Double check. 525.95 minus 254.28 times 5 divided by 3 times cos 30. 158.93. So that is all the tension in the cable. Alright, for part B, okay, because we are out of time, we have 20 minutes left, but okay, so question 2B. Now, why I mentioned that is because if I'm actually in the exam, and you have 20 minutes left, and this is 5 marks, but you have another 20 marks here, so I would go here first, right? So that's my way of thinking, because I don't want to dwell on too much on this question 2B, even though it's just a logical question, but I want to try to secure as much as marks as possible, so I'll shift here. Right, so that is what we're going to do. Right, so this is question 2C. Now in this case, we have this, right? We have small peg, so this peg rests on a spring contained inside a smooth pipe. So when the compressed, so this is compressed, meaning it try to push up, so there's a force upwards on the peg, right? And S is 0.45, so S is here. So this question for me is quite confusing, because you also have F equal to KS, right? So this S is actually this one, not the F equal to KS. So S is 0.15. The spring exert upward 60 Newton. So okay, anyway, so the Newton is already given. So this 0.5 is for the coordinate, basically, right? So the force upwards is already given. So you do not need to find F equal to KS anyway. So determine the point of attachment, so that PB and PC. Okay, so basically you have already the magnitude. So if you draw, so if we draw the free body diagram of the peg here, of peg P, right? So if we draw free body diagram of P, so that P there, so what you have is one is force upwards, and the question says that is 60 Newton, right? Upwards 60 Newton. And then you have F towards B, towards A, towards C, and the question already give that PB and PC, right? So PB is on the left is 30, so this is 30, and PC is 50 Newton. So FPA is not known. Alright, so basically that is the free body diagram essentially, but we have all the coordinates that we need to calculate for the position vector, etc. Right? So in this case, the step is basically you need to express everything in Cartesian vector form, and then find vector for FPA, and then you can find what is needed. Right, so in that case, so this is okay, let's say FPB equal to this one, so FPC equal to this one, right? So, and let's say this is what do you call it, FP, because we just want to label it, right? So now FP is simply 0i plus 0j plus 60 k Newton. FPA, for FPA, okay, this is quite lengthy. R is not PA. PA. Okay, let's for FPA, let's leave it as such, right? So FPA xi plus FPA yj plus FPA zk, because we don't know anything yet here. So FPB, for FPB, so RPB from the coordinate, because this is 0.15, right? So x is, okay, it's not clear, which is the x-axis. Oh, sorry, x-axis here, y-axis here, x-axis here. So this is on the line, right? So RPB 0i minus 0.4j minus 0.15k. It's 0.15, right? The s 0.15. all right. So RPB will be 0 squared plus 0.4 squared plus 0.15 squared. If you square root everything, what you'll get, so it was 0.4 square, 0.15 square, 0.4272 or square root of 73/20. all right. So UPB is RBB divided by RPB equal to, of course, 0i minus 0.4 divided by 0.4272, 0.9363j uh, 0.15 divided by 0.4272, so minus 0.3511k. And FPB is basically, the value is what, 30, so it's 30 times of UPB. So basically 0i, then 30 times 0.9363 minus 28.09j, 30 times 0.3511 minus 10.53k Newton, right? Okay, now, okay, this should be, because this is intermediate, so I should actually take more significant figure, right? Because it's 10.533. Anyway, so that of FPB. What about FPC? For FPC, RPC equal to x is minus 0.3i, y is plus 0.2j to the right, right? Minus 0.15k. So r pc square root 0.3 square plus 0.2 square plus 0.15 square equal to square root 0.3 square plus 0.2 square plus 0.15 square 0.3905. UPC is basically RPC divided by RPC, and then 0.3 divided by 0.3905. So you get minus 0.7682i. 682i. 0.2 divided by 0.3905 plus 0.5122j. 0.15 divided by 0.3905, so it is minus 0.3841 k. Right, so FPC is basically, what's the value? FPC 50, right? This is 50 Newton, right? 50 Newton. Oof. times UPC, which means 50 times 0.7682, so minus 38.41 I. 50 times 0.5122 plus 25.61j, and then 50 times 0.38 for 1 19.21 k Newton. Alright, so we have 9 minutes remaining, so what can we do? Right, so what is this? So what we have is all this in Cartesian vector form. What we need to find is then FPA. So basically, because in equilibrium we have summation of all forces equal to 0, so basically FP that we have plus FPA plus FPB plus FPC should be equal to 0, right? Or in other words, F Bismillah. How to do this? Okay, let's do that one first, right? So if you add together, it will be equal to 0, right? So if you add all the x component, so FP is 0, FPA is FPA, so we'll get FPA, and then FPB we get 0 as well. Okay, so FPC we get minus 38.4, so minus 38.41. This is for I, right? For J we have okay, this is FPAX, right? So FPAY, because that's from, okay, FP is 0, FPA is FPAY, FPB is minus 28.09. minus 28.09, and FPC is plus 25.61, plus 25.61. This is for J. For K, we have 60. So plus we have 60, and then plus FPAZ. And here we have minus 10.53, minus 10.53, and then from here we have minus 19.21, minus 19.21 K. All of this should be equal to 0, right? 19.21. Okay, so of course it takes more time in computer because we have to scroll. Right, so from here basically you can take each and get equal to 0, so you can get the answer, right? So from summation of fx equal to 0, which is the first one here, you can get fpa x equal to 38.41, right? Or it's now the proper way is to write the equation first so that we get all the marks. Where's my mouse? Ya Allah. Oh, it's already down, already at the bottom. Okay, this is also taking time, right? In reality, it will not be this way. Anyway. Okay, so apa ni? Okay, so FPAX minus 38.41 equal to 0, hence FPAX is 38.41 Newton, right? Now, from this one, okay, I'll just copy all of this, right? So this. Okay, so from summation of fy equal to 0, so this should be equal to 0. So so when you are rushing, you tend to become more flustered, right? So it will become 28.09 minus 25.61, so you'll get 2.48 2.48 Newton. Minus 28.09 plus 25.61, bawa ke sana 2.48. Alright, and then for fz, so from summation of fz equal to 0, what you will have is this whole thing. Should equal to 0. So from here, FEZ equal to, you can calculate, if you go there, 60 minus 10.53 minus 19.21, 1 bawa ke sana, minus 30.26 Newton. Alright, so in other words, FPA in the vector is 38.41 I plus 2.48 J minus 30.26 K Newton. Now we have only 3 minutes left, and we are towards the end already, so we are rushing. So if this is actually what is happening, you will lose some marks because of the previous part, and this one is still missing, right? But still we have 3 minutes. We'll try to see how we can. Now the case here is because we do not know the coordinate, right? So the interesting part here is we have point P, which is 0.15 given there, to point A, which is x, y, 0. Now you can get R here, right? So if you have RPA, it will be x I plus y j minus 0.15 k, right? However, the interesting thing here is how to get this value, because that's the question. We need to find x and y. What we have is FPA. So we have FPA vector, we have, right, which is this one. I'm not writing it back. And do we know FPA magnitude? So FPA magnitude you can simply calculate. So using that one, right? So 38.41. So 38.41 square 2.48 plus 2.48 square plus 30.26 plus 30.26 square. Oop. And that will give you, okay, it's the end already, 38.41 square plus 2.48 square plus 30.26 square, you get 48.96 Newton, right? Now if you have these two, okay, again we have to expand the paper. Interesting, it's not enough space, eh? Okay, according to the time, if this is what actually is happening in the exam, you have to actually put your stop writing and put it down, right? So we'll miss the final marks here and 5 marks above that. Hopefully if everything is correct, you get 90%. But we'll just go through this one just for the sake of seeing what would be the answer, right? So in this particular exam, yeah, I do remember some student complain that it's very tight, even if, you know, of course for me I talk a lot, etc., so it takes more time. So even if you do not talk a lot, maybe you only have like 10 minutes extra from now to eliminate the talking, and you still are catching up, right? So yeah, it's quite tight for this exam. Anyway, so from here you can get what is unit vector PA actually. That's one way, because we are trying to find how to find x and y. So let's try to do this. So from this, what I'm trying to say. Okay, so it's basically FPA vector divided by FPA magnitude, right? So if you do this, it's hard when you are scrolling, right? So 38.41 divided by 48.96. So basically you'll have 0.7845 I. Is it positive? Positive. And then plus 2.48 divided by 48.96, you get 0.0507J, and then 30.26 divided by 48.96, so you get minus 0.6181K. 6181K. Alright, so you have the unit vector. If you have the unit vector, okay, what do I need here? Because how to relate this? Because normally if we do know RPA, right, you can know unit vector by dividing these two, right? But RPA we don't also know. But okay, if we calculate RPA, it's quite interesting, right? It becomes square root of x square plus y square plus 0.15 square, right? So in that sense, if we put everything together, because I'm trying to figure this out also, right? So basically RPA divided by RPA would be the same as UPA, RPA. And if we put that together, right, so we will have xi, how to do this, so xi, okay, if we straight away divide by unit vector, divide by RPA, the magnitude, I'll write it down like this first, plus yj over RPA minus 0.15k over RPA. Is it minus 0.15? Minus 0.55. Alright, it should be equal to all of this, right? Astaghfirullahalazim. Okay, it's not even enough space. Oops. Oh, okay. It's not even in the picture anymore. So I'm putting it here. How to do this? Anyway, let's just write it down. It's wasting time, but anyway. 0.7845i plus 0.0507j minus 0.6181k. Right, so what can we resolve here? This is interesting. So what the only thing that we have all the numbers is, not all, but here, right? So if we have the z component, right, so you have minus 0.15 divided by RPE equal to minus 0.6181. From here you can see that, oops, RPA can be obtained with a number, right? So if you put this one, so minus 0.15 divided by 0.6181, so it is 0.2427 meter basically. So if we know this meter, right, so going back here, right, because RPA, this one we don't know, but now we know the actual in magnitude, right? Can we do anything with this? So if we take this question, right, and we know now it is equal to 0.2427. Can we do anything here? So one thing is, then it becomes x square plus y square plus 0.15 square should be 0.2427 square, right? Because we square both sides. So in this case, what we will have is x square plus y square equal to, if we solve this one, 0.2427 square minus 0.15 square, 0.0364, again 0.2427 square minus 0.15 square, 0.0364 square. So this is question number one, equation number one, right? So what else do we have? Because we have to do simultaneous equation. So in this case, RPA, can we do anything about this? RPA, wait, why do I do this, all of this? Because we already have RPA, we can straight we solve here, right? So this is where, because I don't have everything on paper, so it becomes okay. So we already have this, and we already have, when I have already solved RPA, right, meaning down here is already solved, so I can use this and this to solve for x and y. So now, meaning this is not needed. Alright. So going back there, so meaning that x over RPA, so x over RPA meaning 0.2427 should be equal to 0.7845. 0.7845. So x should be 0.19 1904, right? 0.190 meter lah, and dia nak minta in coordinate, right? So okay, so y over RPA or 0.2427 should be equal to 0.0507, 0.0507, right? So from here you get y equal to 0.0507 times 0.2427, 0.0123 meter. Now the question asks what is a in terms of coordinate of x, y, 0. So the answer will be a 0.19, 0.01230. That would be the answer, right? So it's already, if you look down here, it's already 10:10. So if we talk blah 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 there, and I mentioned if I eliminate all my talking time, perhaps we have 10 minutes extra. So we just finish here, but of course if you go back to this point, question 2b, that's remain to be answered, right? Now so let's just glance to there, what is happening there, because here we already covered, right? So determine the point of attachment x, y, 0. Now okay, before we go there, just to touch on what happening here, right? Now even if you do not know, because this pathway I don't even as you saw, right, I didn't even know how to reach it until the end. I'll just keep on trying. As long as you have mathematics, you will find a way. But as I mentioned, so it may take some time for you to realize what you have and what you can do with it. So for example, just now I thought I need to have some simultaneous equation. I didn't realize that, oh wait, when I already have RPA here, just plug in here and I can straightway recalculate to get x and y as we have used at the end, right? So this kind of things, sometimes it comes into the exam where the path to the answer is not really obvious, and you have to just using what you have to extract, rearrange until you find, oh okay, that is the way, right? So that normally if you have enough exercises, it may help because you have experiences many different ways to get to a certain point. For me, I haven't done exercises for a long time. That's why I'm so rusty in this case, right? I know that of course I master the concept, I have teaching this a lot, but it's still mastering the concept, understanding everything you learn in the class is not the same as having enough practices. So if you have lack of practices, like I have the last time I practiced in like how many years before, so it may take some time to come back to you, right? Anyway, so that's a reminder. So make sure you have enough practices before the exam. Now for question 2b, because I want to end as soon as possible. This is already 1:12 a.m. and I want to process this and post before class tomorrow, hopefully. Alright, so what okay, here let's see, cable BC. So we have cable BC replaced with a spring of high stiffness. So spring, one thing, high stiffness meaning it want to meaning if it stretch, it have a strong force trying to get back to its original position, right? And the lamp is replaced by 25 kilogram, so this becomes heavier from 15 to 25. So this heavier, this one have high stiffness, right? What happened to cable AC, which is this one, after the change? Please justify your answer. Now question like this, normally as long as you are going towards the direct direction, normally you will have the marks, because logical questions like this, normally the answer is not just one, right? So if you imagine the force here becomes higher, F towards B, looking at here, it tend to pull it in that direction, right? So meaning the angle here can be more acute from that perspective. But at the same time here, if you increase the weight, so it want to drag down here, right? So this cable DE tend to be drag down there, it want to be more acute as well, right? So you have two, meaning two increment here. So your argument can be so because I'm not the one who make this question, so I'm not sure what is the how they see which kind of element that you put as your answer will get full marks or most of the marks. But if you justify by okay, increase in this tend to basically pull the cable CD to that direction, while the spring will tend to pull in that direction. So it may depend on the stiffness of the spring itself. Is so much stiffness that it drag to the point of towards B. So what will happen to cable EC is basically the angle will shift to become more acute, right? But if the weight of 25 kilogram is much more significant, it will drag into the other direction, right? So as far as from my perspective, that's how I will try to word it. But of course, wording things sometimes takes some time, right? So it's already 1:15 a.m. So that's basically the simulation that we have done for this one. As you notice, this particular exam actually is really demanding in terms of the time usage. As you see, I have exceeded 15 minutes. Of course, I talk a lot, etc. So that's one kind of justification. But still, for if you have lack practices, when you see the question, you do not know how to start, etc., then obviously it'll become much worse. So hopefully you have enough practices, and throughout this I have tried to elaborate how to address each question, etc. Hopefully it helps. Wallahu alam. Hopefully this help. Assalamualaikum warahmatullahi wabarakatuh.